Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is very exciting because we are going to be learning so much. This is rational exponents. And I said exciting, but this could get really difficult because there are so many properties that we have to remember. And I would like you to be patient as we go through these lessons. I have divided the lesson into part 1 and part 2 because there are just so many that it is complicated to learn all of them all in one setting. So our learning objectives, we will learn how to rewrite expressions with rational exponents in radical form. I will learn how to rewrite radical expressions in exponential form. And we would also learn how to utilize properties of exponents to evaluate and simplify expressions. So I am going to introduce you to the first properties that we have to be learning today. So properties of exponent. This is not just the properties of exponent. It's just the first two. Okay, and there's so many of them, but we will be going through them one by one. Okay, something that might not be familiar with you is a number or a variable with a negative exponent, right? It's not something familiar because of course, all the exponents that we have been having, they're all positive. 2 to the power of 3. So 2 times 2 times 2. We have 2 to the power of 5. So 2 times 2 times 2 times 2 times 2. Right? And the exponent tells us how many times we have to multiply the number. But what if that is a negative? What does that mean? And so that is called a negative exponent property. And when that happens, all you have to do is to do a reciprocal of the number. So whenever you have something, a number with a negative exponent, you put that number under 1, right? You do a reciprocal of it. For example, I have a to the power of negative m, right? You will put this whole entire thing under 1. That is now going to look like as 1 over a to the power of m. And please take note, the m is no longer negative. Okay, and that is what we call the negative exponent property. I could also do, for example, a number. If I have 2 to the power of negative 3, I'll put this whole entire thing under, and I'll put 1 on top of it. And that is 1 over 2 times 2 times 2 is equal to 8. So that is just 1 over 8. Okay, so you have to remember, whenever you have a negative exponent, you put that under and then you put 1 on top of it. Now, product of powers. That just says that we're very familiar with that. It just says that when you're multiplying variables that, of course, has the same base, you're just going to add their exponents. And we are very familiar with that. So, for example, you have 5 to the power of 3 times 5 to the power of 8. All you have to do is add the two exponents, and you're going to have 5 to the power of 3 plus 8. So that is 5 to the power of 11. Okay, and that would be our answer. Or you could do 5 times 5 times 5 times 5, 11 times. Okay, but we don't have to do that because our goal in here is just to know what the property looks like. Okay, let us practice, and that is for number 1. Suppose x and y represent positive values, rewrite in radical form. So when you say radical form, we usually call that the square root, right? We don't call it square root because we're not only dealing with square root, we're dealing with cube root, fifth root, sixth root, right? We're dealing with all of those bigger roots. Okay, so we just, in general, call it radical form. Now, how do we convert this into a radical form? I would like you to know, like, how do I know, what do you call this? This is called an exponential form. And we know that that's an exponential form because we can see that there is an exponent, which is 5 over 6. Okay, the I'm going to rewrite that one first. I usually suggest that you rewrite the problem, and you know how to rewrite the fraction into one number over a number. Instead of like side by side, I usually suggest writing that one vertically, like a real fraction that we always see. So 5 over 6. Now, I would like you to know that the number on the top tells you how many x's there are. So if I have x to the power of 5 over 6, the 5 tells you that you have 5 x's. So I'm going to put that x to the power of 5. And then the bottom, this tells you the root of it. So that will tell you the root, and so I'm going to put the 6th in there. And I just converted exponential exponential form into a radical form. So our answer is going to be the 6th root of x to the power of 5. I will repeat the 5 there tells you how many x's you have, and then the 6 will tell you what kind of root it will be. That makes sense? Okay, moving on. Letter B. We are also going to rewrite this in radical form. We have y to the power of 7 over 9. But I'm going to write that one into negative 7 over 9. Okay, take note. There is a negative in the exponent. And I've already said earlier about that kind of property that when that happens, you're putting the whole thing under. And you put 1 on top of it. So let's just do that first. So I'm putting this whole entire thing under. So y 7 over 9 and 1 on the top. And according to the rule, it will no longer be a negative. Okay? And then I'm going to keep the 1 on the top. And I'm going to rewrite this one into a radical form. And we know that the number on the top tells you how many y you have. So that's y to the power of 7. And then the number on the bottom tells you what kind of root it is. So it could be a square root, a cube root, but this time it's a 9th root of y to the power of 7. And there you have it. That's what you're going to do. Okay. I'm hoping that that is not that crazy. Let's go to letter C because we have so many things to go through. Okay, I am going to be doing the same. I am going to write them in a radical. So, let's write that as x4 over 3, y2 over 3, or 2/3. Okay? I will repeat. The number on the top tells you how many x's you have. The number on the top tells you how many y's you have. And the numbers on the corner, on the bottom, tells you what kind of radical you have. If you have a cube root or a 4th root or something. Okay, I'm going to write that equals. So that is 4 x to the power of 4, right? And it's going to tell me what kind of root it is. So it's a cube root. And then I'm also going to write y. But then, 2 y's, right? Y times y, or y squared. But then, you know how I already have a 3 in here? Luckily, this one is also a 3. So they could just reside all together in one radical because they share the same denominator. They share the same root. So I can just put them in inside. Now, you know how over here I did not simplify it? Because take a look in here. Does the 6 go to the 5? In the previous lesson, right? Does the 6 goes to the 5? No, there are no 6 in the 5. So I will keep this as my final answer. Now, moving on over here, does the 9 go to the 7? Are there 9s in the 7? No. So I'm going to keep that as is. But when you look over here, it looks like the 3 can go to 4 one time. There are 1 3 inside the 4. So I still can simplify it. But what about the y? Can we? Are there any 3's in the 2's? No. So I'm going to keep this y squared as is, but I am going to simplify the x to the power of 4. So this is equal to, again, I am going to change the color there. So we have cube root of, I think I am invading let's put that at the bottom. I'm going to x to the power of 3, x to the power of 1, y squared equals, we already know that because the 3 goes to the 3 perfectly, this gets canceled and this x goes out. So x goes out. I could call that x to the power of 1, or you can just call it x. But then because this 3 does not go to the 1, the x stays in. This 3 does not go to the 2, so the y squared stays in. So our final answer is going to be x times the cube root of xy squared. So let's circle all our answers there. Okay, moving on. We have x to the power of 13 over 5, y to the power of negative 5 over 8. So let us rewrite them. We have, I'm invading this space, x 13 over 5, y negative 5 over 8. And remember that we've already learned it before, that when we have a variable with a negative exponent, that goes down, right? So we are going to move this under. Does that make sense? So I'm going to, wait, let me copy that answer here. Xy squared, so that we have a bigger space. Does that make sense? So arrow. Okay, so this is x 13 over 5, y to the power of negative 5 over 8. And because this is a negative, it goes down. So I'm going to keep my x to the power of 13 over 5 on the top. And then I will put y to the power of 5 over 8 at the bottom. Miss, that doesn't seem like the same as what you did in B. Because in B, you put this on the bottom and you put 1 on the top. So technically, that's what I did. Because if I put the 1 on the top over here, right? If I do, let me write it. If I do 1 over y, I'm going to erase it after though. If I do 1 over y to the power of 5 over 8, so that means I have this times 1 on the top. Would the 1 matter? No, right? It would just still be x to the power of 13 over 5. So I have to just delete that, and I can just automatically put y to the power of 5 over 8 at the bottom. Okay, so since they have different variables, I am going to solve them separately. So I'm going to solve the 13 first. The 13, or the one on the top, tells you how many x's do you have, and the 5 tells you your root. The one on the top tells you how many y's do you have, and the 8 tells you the root. Okay, can we still simplify? Are there 5's in the 13? There are 2, right? There are 2 5's in the 13, and you have 3 left. So how do you simplify that? You could simplify that right away, but I could also do it as x to the power of 10, x to the power of 3 over, I don't think there is 8 in the 5. There's nothing, right? So I can keep that the same, but I can simplify that. So that would be, let's put the answer. On the bottom, I am going to have, the space is very limited, equals. I have, how many times the 5 goes to 10? Twice, right? Or 10 divided by 5. So I have an x squared on the outside, and the 5 does not really go to the 3, so I'm going to keep that in, over 8y to the power of 5. So your answer is going to be x squared times the 5th root of x cubed all over 8, the 8th root of y to the power of 5. Okay, there you have it. So let us go to number 2. We have 1 over the 4th root of x cubed. All we have to do is we're going to do it backwards. You know how earlier I have it in exponential and then I'm going to move it to to rewrite it to radical. This time I have a radical and I have to write that into exponential. I am going to keep the 1 on the top because there is really nothing we can do with 1. So that is just 1 over. And then it looks like, remember, the x cube, right? The 3 tells you how many x's you have. So that goes to the top. And then the 4 goes into the bottom. Because if I have to rewrite this in radical, like if I do it backwards again or reversed again, the x cube is inside because this tells how many cube do we have or how many x do we have, and then the 4 goes inside. So that's it. That's your answer. And you cannot really simplify 3 over 4 anymore, right? That is already the proper fraction. And that's your answer for letter A. Letter B, we have y cubed times y. The 2 goes on the top and the 7 goes on the bottom. I am rewriting radical to exponential. And then do you remember that property that I told you earlier, that when we are multiplying two variables that are the same base, right, y and y, we could just add their exponent. Do you guys remember? So we add the exponent, and that is y to the power of 3 and 2 over 7. And we can convert that into improper fraction. Do you guys remember how to do that? We multiply these. So 7 times 3 is 21. 21 plus 2 is 23. So this is 23 over 7. So our answer is going to be y to the power of 23 over 7. Okay, moving on. We have 1 over the 6th root of x times y to the power of 5. You need to be careful because you see this. Oh, let's put the 1 first. Okay, 1 over. You need to be careful because this x is inside the 6th root, right? So this 6th belongs to x and it also belongs to y. So when you rewrite that, you are going to do x. How many x do we have? I have 1x in the 6th root. How many y I have? I have 5 y's in the 6th root. Right? And can I still simplify 1 over 6? No. Can I still simplify 5 over 6? No. So my answer is going to be just like that. All done. Letter D. Again, we're dealing with a negative over here, so we have to do something about that later. But for now, let us write that on its own. So we have y to the power of negative 5. Y to the, how many y's do we have? We have 3 y's under a 4th root equals, and remember, right? Remember the rule that is called product of powers, that when we are multiplying variables, we can add their exponent. So I am going to add negative 5, so that is y, to the power of negative 5 and 3/4. So that is why, let's convert that into a improper fraction. 5 times negative 5, sorry, 4 times negative 5 is a negative 20. Negative 20 plus 3 is negative 17/4. And remember, it says here in our instruction, suppose x and y represent positive values, rewrite in exponential form, use only positive exponent. And because we ended up with a negative exponent, do you remember what to do? I am going to put that under, make it positive, and put 1 on the top. So my final answer is going to be 1 over y to the power of 17/4. I could actually convert the 17/4 into a mixed fraction, but I don't have to do that because that one isn't enough answer. Okay, so let's move on to the next one, number 3, which is a little bit difficult again, but this is something that you guys can do, and I am very positive that you can do this. Negative exponent, wrong pen. Negative exponent, we already know, we have to flip it. We have to do a reciprocal. Product of powers, we already know. When we multiply two variables that are of the same base, I can just add their exponent. So like x times x squared, right? X cubed times x squared, x to the power of 5, because I'm adding the exponent. And that is something familiar. We also have what we call quotient of powers when we are dividing two things that have the same variable, like a over a, 2 over 2, things like that. You can just subtract the exponent. And that is very familiar with us because we did x to the power of 5 divided by x cubed. It's x squared because I subtracted the exponent. Okay? I want to focus though on what we call power of a power. Okay? When an exponent has an exponent also. It seems complicated, yeah? So a power of a power. When that happens, you can multiply the power. Let me make that bigger. So if you have a to the power of m to the power of n, you can multiply this. And you're not touching the bottom though. You're not touching the base. The base stays the same, but it will be a to the power of mn. So if I have a number, like say 7 to the power of 3 to the power of 5, I can multiply this and I can say that that's 7 to the power of 15. That make sense? Okay? So whenever that happens, please know that we can multiply the two exponents. Okay, let's try like this. That is too much to remember, I know. Okay, here, there's so many ways. Like maybe if you search in YouTube or whatsoever, you'll see other ways of simplifying. Because right now, we're not just writing it into exponential to radical. We're not just doing that. We are being tasked to evaluate it. So of course, we're tasked to do it in a radical, but first, our task is to evaluate it. Okay? So we're only putting it in a radical when it's necessary. So let's try to see if we can evaluate it first. 9 to the power of 3 over 2. Usually what I suggest is, think of 9, right? What is 9? If we make a tree, 9 is 3 times 3. So 3 squared, right? So if I convert the 9 into a 3 squared, I mean, I am not really changing the number. I'm just simplifying it, right? So I could get a better idea of what's the simplified version of 9. 3 squared. 3 times 3. And then to the power of 3 over 2. And I have said earlier, power of a power. That when you have two powers, right, separated by a parenthesis, you have two powers, you can multiply the two powers. So what does that mean? Does that mean that I can multiply 2 times 3 over 2? Yes. And remember, when you multiply, there's technically a 1 in it, right? So that means 3 to the power of 6 over 2, right? Or 3 to the power of 3. What is 3 to the power of 3? 3 times 3 times 3. The answer is 27. So the answer for number 3 is 27. That makes sense? Okay, hopefully it does make sense. All right, 16 to the power of negative 3 over 4. You can put this one under now because it has a negative exponent. We know it goes under. So we can do that now or we can do that later. And we can just like simplify it first. It doesn't really matter what you do first. But we can simplify it now and put this under. So I am going to be dealing with a positive 3 over 4 equals, what is 16? Well, we know 16 is 4 times 4. We know that that is 2 times 2. It's 2 times 2. So 1, 2, 3, and 4. So instead of writing 16, can I write it as 2 to the power of 4? Right? So 1 over 2 to the power of 4. 3, I'm not following my own rule. 3 to the power of 4. And we know that property, right? The property of exponent called power of a power. We know that we can just multiply the two powers. So that is 2 to the power of, technically you can cancel that, but we're going like really in detail. So that's 12 over 4. So that is 2. Oh, I am forgetting, you guys. I am forgetting. That is supposed, let me just take that out. Because you already know that, right? So I had to do 1. I keep forgetting this one. That's 2 to the power of 12 over 4. That's 2 to the power of 3. So what's 2 to the power of 3? 2 times 2 times 2. That's 1 over 8. So our answer here is 1 over 8. Okay? Moving on. 64. What is 64? 8 times 8. 8 times 8 is 2, 2, 2. 2, 2, 2. Right? Because 8 is 4 times 4. Oh, sorry. Hello. 8 is 4 times 2. So that is 2 times 2 times 2. Okay, so we have how many 2's? 1, 2, 3, 4, 5, 6. So 2 to the power of 6. So instead of writing 64, can I write 2 to the power of 6? And then I'm going to erase that 2 to the power of 3 over 8. And it's not a negative, so I don't have to put that at the bottom. So this is going to be 2 to the power of 18 over 8. Does that make sense? 18 over 8. And then, I think I can simplify 18 over 8, can I? That is going to be 2 to the power of 9 over 4. And now, I am going to put this in a radical. So, miss, I don't get it. Why you didn't put the 27 in a, you can't put that in a radical because that doesn't have an exponential exponent. You can't put that in a radical because it's a fraction, right? This, it has an exponent that is a fraction. She can put that in a radical. So, you can either break that down now or break that down later when it goes in the radical. It doesn't really matter. So, let's put that in the radical before we forget the process. Okay, the 9, I already told you that. The 9 tells you how many 2's you have. So, it will tell you you have 2 to the power of 9. And the 4 at the bottom tells you what kind of radical it is. Or what kind of root it is. So you have the 4th root of 2 to the power of 9. Now, question. Can I still simplify these? Are there 4's in the 9? Yes, there are actually 2 4's in the 9. So I could simplify that one more time into 2 to the power of 8 times 2 to the power of 1. That makes sense? And then our final answer would be how many 4s into the 8? There's 2. So you have 2 squared on the top, on the outside. And then the 4 does not really go to 1, right? So we are going to leave that inside the house. And can we still simplify this? This is going to be 2 squared. 4 and the 4th root of 2. So that is our answer. 4 times the 4th root of 2. I know it's a lot of work. Okay, now we have letter D. And we already know what D means. We know what that rule is, right? Do we know what rule this is? This is called exponent, power of a power. So I can just multiply the two powers. Or I could simplify this first and then do that. It doesn't really matter. So let us do, my problem is like this ways. So I have 8 to the power of 1/4 times 5 to the power of 6. So this is 8 to the power of 5 over 24. Right? Well, can I simplify 5 over 24? Can we simplify 5 over 24? So there's not really anything common in that, right? But can I simplify 8? What is 8? Okay, 8 is 2 times 2 times 2. So let's see if we can simplify that into 2 to the power of 3, closed, 5/24. So you can multiply again. That is power of a power. I can multiply 3 and 5. That is 15 over 24. Can I simplify 15 over 24? It looks like I can divide both by 3, right? So that is 5 over 8. Because 15 divided by 3 is 5. 24 divided by 3 is 8. Okay, now I can put this in a radical. The one on the top tells me how many 2's I have. So that is 2 to the power of 5. The one on the bottom, what is that? The one in the bottom tells me what kind of radical I have. So my answer is going to be the 8th root of 2 to the power of 5. But there's so many things to do, right? It looks like you can still simplify 2 to the power of 5. What is that? 2 times 2 times 2 times 2 times 2. That is a 32. So our super final answer is the 8th root of 32. Okay. That was a lot. Okay, let's have 64 to the power of 2/3, 64 to the power of 3 over 2. There are so many ways you can do this. You could actually, because you know how when you have the same exponent, the same base, you can subtract the exponents. You can just subtract the exponent right now, or you can simplify it first on its own and then subtract the exponent after. So whatever you do, it should not be a problem. But I would like to subtract the exponent right now because 3 over 2. Okay? And they don't have the same, what's that called? They don't have the same denominator, so I'm going to multiply this by 2, multiply this by 3, right? So the denominator is 6, so I have 4 minus 9. Does that make sense? 2/3 minus 3 over 2 is going to be 64 to the power of negative 5 over 6. And we know that when it's has a power of a negative number, we have to flip it. So this is 1 over 64 to the power of 5 over 6. And now we can simplify 64. Let's make a tree. 64 is 8. Oh, we don't have to do that because we already did that earlier. So 64 is right here already. That's 2 to the power of 6. So this is 1 over 2 to the power of 6, parenthesis 5 to the power of 6. This is 1 over 2 to the power of 30 over 6, right? 6 times 5. Or you can, you know what? You can just cancel that and say that that is 2 to the power of 5. I just would like to show you guys like how it's done, but you could just really cancel that. And then this is 1 over 32. So our final answer is 1 over 32. Okay, last one. We have 16 over 81 to the power of 3 over 4. Now, who owns 3 over 4? Let's change the color. Who owns the 3 over 4 over here? This 3 over 4 or 3/4 is owned by both of them. So what I would like to do is I would like to give it to them. So 16 to the power of 3 over 4 over 81 to the power of 3 over 4. And I would like to simplify them on its own. So what's 16? Did we have 16 earlier? I think we did 16 now. 4 times 4, right? So 16 is, let's put that down here. Okay, 16 would be 4 times 4. And when you do 4 times 4, you do 2 times 2, 2 times 2. So you're going to end up with 4 2's. So I'm just going to write that, and hopefully you are, 2 4's. 2 to the power of 4, 3 to the power of 4. And then for 81, that's 9 times 9, 3 times 3, 3 times 3, 1, 2, 3, and 4. So you have 3 to the power of 4, 3 to the power, I keep forgetting that, 3 to the power, 3 over 4. So you can cancel that, right? Because that's 12 divided by 4. So that's 2 to the power of 3. Cancel. 3 to the power of 3. So that is 8 over 27. And I don't think you can still simplify 8 over 27, right? There's nothing in common between 8 and 27. So 8 and over 27 would be your final answer. Okay, there you have it. That's the end of part 1. Thank you guys for your patience, and it's a good thing. It's a good thing that I know it's hard and know there's so many things to remember, but the good thing here is that you can watch the video over and over and over again, so that when you forget, like, oh, how do you do that? You can just click the video and rewatch it. Okay, thank you for your patience, and I do hope that this lesson helps you understand how to manipulate and how to evaluate rational exponents. Thank you, everyone. I will see you in the next video.